Hi, welcome to our next level 3 trigonometry video. We're now going to turn our attention to modeling graphs. In other words, using the trigonometric equation we've been developing to model real life applications. We've got two examples. This video is the first and the next video is our second example to show you some of the ideas you need to be familiar with. Alright, let's get into example 1. This beautiful place called London has an amazing Ferris wheel called the London Eye, and it is one of the largest Ferris wheels in the world. The height of a particular capsule above the ground can be modelled by a trigonometric function. Now here's some key information that we need to know. The centre of the circle is 68 metres above the ground. The maximum height of the Ferris wheel reaches 135 meters, and the wheel takes 30 minutes to complete a revolution. It takes 30 minutes for one ride. All right, so here's what the trigonometric graph model will look like. Now we're going to figure out the values of A, B, C, and D. Okay, now we know the center of the circle is 68 meters above the ground. So we know the total height of the graph is 135 meters. What I'm going to do is I'm going to work out the difference between 135 and 68, and that gives me 67. When I subtract 67 off the 68, we realize that the graph doesn't go all the way back down to 0. It actually goes back down to just 1 meter, which means the capsule comes down and is 1 meter off the ground when it goes around on its journey, on its ride. So from this information, I know that the amplitude of the graph is 67. So A is 67. I also know the vertical shift is 68. The graph has moved up 68 meters. That's the center of the circle, remember? Right, now this here is our normal cosine, this bit in light orange, and it is a normal cosine that starts at its maximum. We are going to flip it upside down and treat it as a negative cosine, and we're not going to shift it anywhere sideways. So therefore there's no horizontal shift, so C is 0. Now, we now need to work out the value of B. To do that, we need to work out the period of the graph, which we were told is a 30-minute ride. So period is 30 minutes. It takes 30 minutes to complete one cycle. So we're going to use this formula. Period is equal to 2 pi divided by B. We're going to flip period and B over. So B is equal to 2 pi divided by the period. So it's 2 pi divided by 30 because the period is 30 minutes. And 2 pi over 30 simplifies down to pi over 15. So we've got the value of B to be pi over 15. Right, well we have all our values we need, A, B, C, and D. We're going to put them all together in our equation. So here is the equation, y equals A cosine, it's a cosine, we're treating it as a cosine. We put B out the front of the brackets. In brackets, we go x plus or minus c, close brackets, plus or minus d. So A is 67. Now we're putting a negative 67 because we want it to be a negative cosine. Now we're putting B in, which is pi over 15. Now we have no horizontal shift, so we don't need to put C in the brackets. And then we put plus 68, which is D. Now because we don't have a C, we can bring the B into the brackets and write it as negative 67 cosine B times x in the brackets, so pi x over 15. Now the last thing we're going to do, because we're talking about height and time instead of y and x, we're going to replace the y with height, and the x with t for time. So our model is h is equal to negative 67 cosine bracket pi t over 15 plus 68. Cool, thanks very much for watching.